So today we're going to do a lesson on 10.6, which is going to be conditional probability. So two or more events are dependent if the occurrence of one event affects the probability of the consecutive events. This changes the set of possible outcomes for our consecutive selection. When two or more events are dependent, the conditional probability exists. It is the probability that some event will occur given another event has already occurred. For any two events A and B, the probability that event B occurs given that event A has already occurred can be written by the statement or equation: probability of B given A is equal to the probability of A intersection B over probability of A. So I want to talk a little bit about how you've kind of already seen this formula before. So algebra is a consistent theme throughout all math courses that you take. So you learned in 10.4 about this particular formula. You learned that the probability of A and B is equal to, and you don't have to write this down if you don't want to, the probability of A times the probability of B given A, correct? Do you remember doing this in 10.4? Isn't this the same formula over here? Isn't it just rearranged? What did they do to get from the formula in the pink to the one in the black? They divided by P given, probability of B given A, correct?
Yeah.
So these are the same formula, now we're just working with it differently, okay? So instead of doing multiplication, we're going to be doing division. Alright, so let's go ahead and try one of the problems. So, excuse me. Of two math tests, 25% of the class passed both tests and 42% of the class passed the first test. What percentage of those who passed the first test also passed the second test? So, in this question, you're going to figure out which one of these is the intersection of events. So, is the intersection of events the 25% or the 42%?
25%.
Good. So the two events occurring simultaneously over one of the events occurring. Okay, and that's all you have to do. You do that math, and when you do the math, you get 60%. So that's the percent of those who passed the first test also passing the second test. So these are the percent of people who also passed the second test given they passed the first test. Okay, passed the second test given they already passed the first test. Does that make sense how we did that? Now every one of these problems that you do, you can use that logic, but I also want to give you a hint. The smaller of the two fractions or percentages, decimals, whatever you want to call them, have to be on top. Okay, the smaller of the two has to go on top. So a jar contains black and white marbles. Two marbles are chosen without replacement. The probability of selecting a black marble, then a white marble is 0.34, and the probability of selecting a black marble on the first draw is 0.47. What is the probability of selecting a white marble after drawing a black marble? So which number is going to go on top here?
34.
Good, because that's both events happening at the same time over the single event happening. So keep in mind, two events happening together is always going to be a smaller chance than one event happening. So that's why the probability on the top will always be smaller than the probability on the bottom. And if we do that math, we get approximately 72%. So there's a 72% chance of drawing a white marble after drawing a black marble. Okay? So do we have any questions about that? Okay. The probability a student is absent on Friday is 0.03. Since there are 5 days in a week, the probability that it is Friday is 0.2. What is the probability that a student is absent given it's Friday? So this is something that's already been calculated. We calculated the probability that a student is absent on a Friday. Okay? We also know that Friday is one of 5 days in the school week, correct? Which means if I were to pick a random day out of a bag, so say I put Monday, Tuesday, Wednesday, Thursday, Friday in a bag, and I were to pick it out, what would be the chance of picking any of those? 1 out of 5, which is 20%, correct? So that's where the 0.2 comes from. So what you would do here is the chance of being absent on Friday out of the chance that it's first Friday to begin with. Okay? So that's going to give you 0.15, or
15%.
15%. Okay. Alright. So that's all I have for the notes, but just to mention on the homework number 1, a lot of people were asking me about that question. That's a two-parter. Make sure that when you do that problem, my hint to you is, because you're going to be doing 2 separate fractions. The first one, A, is going to deal with only things that people had to have pets versus now versus past. B is going to be no pet with no pet. So look for the fractions that deal with no pet, look for the fractions that deal with a pet. That's going to be your answer. Alright, so you have the rest of the period to work on that, or the practice